Assalamualaikum warahmatullahi wabarakatuh. Welcome to Wisdom International School's digital classroom for mathematics. So we'll do this chapter introduction to Euclid's geometry today. Just we are going to review the definitions and axioms and postulates. That's all. Okay, we don't have to do any exercise from this, but you have a lot of definitions and postulates here. So you have to write down these notes. See, I have given few notes. Just have to write down all these things in your geometry classwork. That's the homework for today. Okay, so with that we end this chapter. Okay, so now see, Euclid, he is known as the father of geometry actually. So here, see, he has given few definitions. Actually, he had given 23 definitions. So there are 7 of them given in your textbook. See, a point is that which has no part. That is, it doesn't have any part, right? This side, left side, right side, up or down. You don't have anything. So it's just the definition of a point he is saying. Okay, it has no part. A line is breadthless length. Okay, so if you have a rectangle, you know what a rectangle is, right? So rectangle has a length and the breadth, but then this line is a breadthless length. We don't have a breadth for this. So if you don't have a breadth, you get a length only, right? So that is what is they're saying. Okay, it's just a definition it's being told. So it's all things which we already know. The ends of a line are points. So the line has a points. The ends are always a point. Okay, and a straight line is a line which lies evenly with the points on itself. Okay, it's a line, straight line. So they're just telling the definition of a straight line. It's a line which lies evenly, that is, the points lie on itself. So there are many points lying on this line. Okay, now a surface is that which has length and breadth only. So if I say a surface, it talks about just the length and breadth. Understood? So you have a length and a breadth. That's what is your surface. Like a paper, it has a surface, right? Or a plain surface. When we say it's not a thick object, it's not a three-dimensional object. Like you don't have a box, like a box or a ball. These doesn't come under the surface. Surface is a plain flat surface. Okay, now the edges of a surface are lines. Okay, so the edges, you understand the meaning of edge, right? These corners, these edges, these are the edges. So like in rectangle you have 4 edges, right? So the edges of the surface are always lines. Okay, now a plane surface is a surface which lies evenly with the straight line on itself. So plane surface is, again, it's not like, when I say plane surface, it's a flat plane surface which lies evenly with a straight line on itself. You have a line on itself, right? Okay, alright, so now you get postulates. So we are going to learn few postulates and axioms. So first let's look at the definition of postulates. So postulates is assumption specific to geometry. That is, based on geometry, when you give a assumption, when we assume things based on the geometrical concept, that is called as the postulates. Axioms are general to everything in math, okay, except it's not just like stuck to geometry. It's not specific to geometry. It's just the assumption throughout the math. Okay, mathematics. All right, so now Euclid's axioms, not in his order, are given below. So this is not in the order what he has given, but whatever, we have learned we have 7 axioms to learn. So these things you have to just copy down in your classwork. So based on this you may get multiple choice questions like fill in the blanks or anything based on that. Okay, so things which are equal to the same things are equal to one another. We know this, right? See, if there are 3 surfaces, A, B and C, and if I say that A is equals to B and A is equal to C also, then B has to be equal to C, right? So that is what it says, things which are equal to same things. If A is equal to B and A is equal to C both, then B and C will turn out to be equal. So that's what it says. Now equals are added to equals, the wholes are equal. So if equals are added to another equal, okay, if 2 equal parts are added to each other, then the wholes, whatever answer you get, that will also turn out to be equal, right? Like if A and B are equal to each other, as I said, A is equals to B and I am adding some C to both of them. Okay, so the answer what I get, both are going to be same because A and B are equal, and what I'm adding to both of them are again equal. So that's what they say. If equals are added to equals, the whole in the sense, the answer what we get, that's also turning out to be, that will also be equal to each other. A plus C will be equals to B plus C. That's what they say. Okay, same way, if equals are subtracted from equals, the remainder are equal. So the same concept applies for the subtraction also. Now, things which coincide with one another are equal to one another. So obviously if there are things which coincide with another, let's say there's one line and you know there's another line. Let me use another pen color for this. Let's say, you know, there's another line which is coinciding on like, you know, if I make them lie above one another, it actually coincides, right? So if it is coinciding, that means that they both are equal to each other. That's it. Okay. Now the whole is greater than the part. Now what do you mean by a whole and the part? See, if I say that there is a surface, okay, let's say this is the whole. Now a part of it, let us say this whole thing, this page, there is a page, okay, this is the page, the full page, the green page which I have drawn. Now on this I have just, you know, cut a part of it. Let us say a red part has been cut like this. So this is called as the part, and the whole thing is like from where this part has been taken, this green thing is the whole. Okay, so they are asking you, they're saying that the whole is greater than the part, obviously, because the part is just a part of the whole thing, right? So that says it's always greater than the part. Now next one is things which are double of the same things are equal to one another. Now if you have, you know, two things equal and I'm doubling this, now A and B are equal, let us say. Now I'm doubling A, that is, it becomes 2A, and I'm doubling B also, so 2B, so that's going to be equal to each other. So that's what it says, things which are double of the same things are equal to one another. Now things which are halves of the same things are going to be equal to one another. The same thing applies over here, right? If you have two chocolates and the two chocolates are, let's say, you know, you have 5-star chocolates, two equal length 5-star chocolates, and you are just, you know, breaking them into half. Both the two chocolates are broken into half, so the half will also turn out to be equal to each other, right? So that is what it says. Okay, so these are Euclid's axioms. Okay, so these axioms are just based on, it's specific to the whole math. Okay, it applies to, it's not just applicable to geometry, it is applicable to the whole of math, not just the geometrical figures like, you know, a plane or a square or a rectangle or a cube, not just sticking to this, but you have it applicable for everything, like, you know, algebraic equation or any kind of a problem in maths. Okay, so now we have 5 postulates. So you people can remember this, write it down and memorize this. You may be asked, you know, to write, like, you know, when a written exam is there, you may be asked to write 1 or 2 postulates. So, you know, you should know, it's better if you remember all the 5. Okay, so the first one says, so when I say postulates, these are for geometry. Okay, these are specific to geometry. Okay, so a straight line may be drawn from any one point to any other point. So that means that, you know, if you have two points, let's say there's one point and there's another point, so a straight line can be drawn joining these 2 points, right? So this is a known thing, and it's specific to geometry actually. Okay, see, when you have 2 points on a plane, you can join these points, and you know, and you know, the line which is joining these 2 points is going to be a straight line. So again, you know, see, there's one axiom in this. Given 2 distinct points, if 2 points are there, there is a unique line that passes through them. So there's just one and only one point which passes through these 2 points. Okay, you can't draw more than one line can be drawn. You can't draw more than one line. Okay, you can, if you try to draw another line like this, you know, there's one line, let's say going till here and then this coming back here, this is not one single line. This turns out to be 2 lines. See, from here to here there's one line, then, you know, when it bends, it turns out to be another line. So the line, it's called as a straight line when there is no bends or turns or twists, right? So they can be just one straight line joining 2 points. Now a terminated line can be produced indefinitely. So a terminated line, like, you know, you see, you can, if you want, you can just, you know, produce the line as long as you want. You know, you can just, you know, if you want, you can extend it to how much ever length you want, right? So that's what they're saying. If you want, you can produce the line indefinitely. That is, you know, it can go to infinity. Okay, now a circle can be drawn with any center and any radius. If you want to draw a circle, you can draw many circles, right, with any radius and any center. You know, anywhere you can draw a circle. Okay, all right angles are equals to one another. So all right angle is 90 degree, right? So anywhere you draw it, like this or like this, you know, it's going to be 90 degree wherever you draw, right? So all right angles are equals to one another. Like in whichever shape you draw, it's going to be 90 degree only, correct? Okay, now the 5th postulate is little, you know, complicated, so we have a better way to understand it actually. So let's first read this. Okay, if a straight line falling on two straight lines make the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of the angle is less than two right angles. So now I'll explain this with, there are two better ways to understand that. So you can come to this equivalent version of Euclid's fifth postulate. Okay, so this fifth postulate is, since it looks very complicated, there are two equivalent ways they have given. Okay, so the first one is called as Playfair's or axiom. So that says, for every line L and for every point P not lying on L, let us say there's one line L, okay, this is line L, and there's a point somewhere on not lying on L. Okay, so you can draw a point anywhere but not on L. Let's say there's a point over here. There exists a unique line M passing through M and parallel to L. So if you want to draw a line parallel to L and that has to pass through this point, then you can draw just one and only one line. Okay, you can't draw more than one line. Okay, there could be only one line which is parallel to M, which is parallel to L and passing through the point P. If you want, you can draw many parallel lines, but not all the lines will pass through P. So if you want to draw a parallel line which passes through any point on a given plane, then that will be just one particular line. Okay, one unique line. So that's what it says. Okay, and the second thing says that two distinct intersecting lines cannot be parallel to the same line. So now let's say there are two lines, okay, which are intersecting to each other. Now these two lines both can't be parallel to the same line. If you have one line, like, if you want to draw a parallel to this line, you will draw it over here. This will be parallel, these two will be parallel, but this will not be parallel, right? Or if you want, you can draw the line which is parallel to this line. Okay, these two will be parallel in that case, but this will not be parallel. So you can't draw a line parallel to both the intersecting lines. If two lines are intersecting, then you can never draw a line parallel to both of them. You can just draw one line parallel to any one of them. So if the line is parallel to both the lines, then both the lines are supposed to be parallel. Only then you can draw a line parallel to both of them. Understood? So that's what is your Euclid's fifth postulate could be written in two ways, these two. Okay, now you come up here, it says theorem 2. There's just one more theorem, small theorem. It says two distinct lines cannot have more than one point in common. So let us say that there are two lines. Okay, these two lines if they are intersecting, they will intersect at only one point. You can't have more than one point which is common to both of them. This point is common to this line also and to this line also. You can't draw more than one point common to both of these lines. Okay, see, if you want to draw like this, okay, see, there is a point over here and there's a point over here. You may say that there are 2 points lying on the line, but then there are 3 lines here. This is line 1, this is line 2, and this is line 3, right? So if we are talking about 2 lines without any bend, a straight line, they can meet at only 1 point, not more than 1 point. Okay, so that's what they say. The common point is nothing but point where it intersects, okay, where it crosses each other, intersecting points. Okay, so that's all. So you just write down all these things and understand well. You may have problems based on this, not problems actually. Usually they give definitions in this chapter, from this chapter. Okay, so that's all for today. Allah Hafiz. See you with the next video, inshallah. Allah Hafiz.